Hey, fellow mathers! Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians, welcome to the podcast where math is figureoutable. I'm Pam.
And I'm Kim.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms really not helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be.
So in the last 2 episodes, we've been answering a question from a follower of our Math is Figureoutable teacher Facebook group, and we've been diving into fraction division. So today we're going to hopefully finish and continue to answer Beth's question.
So I'm going to be honest, it might be our last episode that we do on fraction division for a minute because we have some other things we're going to do. I don't know that we're going to finish fraction division today, but I think we'll give you some really good things to think about and continue your journey, at least about thinking quotitively about fraction division.
Yeah.
So what about fractions divided by fractions, especially fractions where their denominators are not factors of each other? I say that because in last week's episode, we did a bunch of fraction division problems, things like thirds divided by sixths and thirds divided by twelfths. Mm-hmm. And so thirds and sixths and 3 and 6 and 3 and 12, 4 and 12, those are all related. Right. They're factors of each other. And so there's maybe some different thinking that happens. And so today we kind of wanted to dive in. What if the fractions are not quite as nice? And let's do it. Are you ready, Kim?
Yep.
All right. So your first problem today, I'm getting my pen out. Do you have your pencil out?
I do, of course. Good eraser?
Yeah, I have no eraser because I have a pen. I have a gel pen today. Let's see if it smears on my... Actually, I have a really nice gel pen. I don't think this one smears. Anyway, moving on. What is 3 divided by 2? And I know we said fraction division, but bear with me. What's 3 divided by 2?
1.5.
Okay. And I was going to write 1.5 until you said 1.5. And then I wrote 1 in the fraction 1/2, but it could be either, right? 1.5, 1.5. Mm-hmm. How do you know?
Because I can think about it like I can fit 2 into 3 one time. Like there's room for 2, but then I can only fit 2 into 3 1/2 again. So there's already 1.5 2s and 3. Yeah.
1.5 2s and 3. So you're really thinking quotitively, which I kind of asked you to. Yep. How many 2s are in 3? And you're like, well, I can fit a whole 2 in 3.
Yep.
But I've only got 1 left over. And how many 2s are in that 1 left over? Just a half. Cool. Okay. So you can think about 3 divided by 2 is 1.5. Listeners, if you've never thought about something like that, 3 divided by 2 quotitively, if you've never thought how many 2s can I fit into 3, you might want to pause the podcast and think about that maybe a little bit more before we go on. Maybe, maybe think about how many, like if I said 5 divided by 2, you might want to think how many 2s are in 5, kind of see if you can kind of make some generalizations about that. Okay. So next problem. What about 3/6 divided by 1/6? 3/6 divided by 1/6. What do you got?
3. Because there's 1/6 3 times in 3/6.
Cool. And so I could draw, in fact, I should have maybe talked about 3 divided by 2, I might have had 3 candy bars. And in this case, I'm going to say if I wanted to share that with 2 people, no, that's not how I want to say that. Nope.
Yeah.
Nope. I want to say if I'm going to give, no, how would I say that? I hadn't thought about a model for this one, Kim, ahead of time. And that wasn't smart on my part.
Well, I was just thinking about, like if a one size candy bar is 3 pieces long and another size candy bar is 2 pieces long, how many of the 2-piece candy bars would fit in the 3-piece candy bar? Or the 3, like 3 bars long, like if it's an extra large candy bar.
The pieces would have to be the same size, right? So how many 2-piece candy bars can fit in a 3-piece candy bar?
Yeah, like a Hershey's
That's
bar.
perfect. Perfect. Nicely done. Cool. All right. So we've got 3 divided by 2 is 1.5. 3/6 divided by 1/6 is 3. What's 3/6 divided by 2/6?
Oh, you just asked me 3/6 divided by 1/6, and that was 3. But now the pieces are twice as big, so there's going to be half as many of them. So it's going to be 1.5.
Because half of 3 is 1.5. Yeah. So you kind of used the relationship with the problem before. So if I say 3/6 divided by 1/6 is 3, then 3/6 divided by something twice as big has to be the answer's half as much.
Yeah.
So 3/6 divided by 2/6 is 1.5. Can I say that in a slightly different way? Sure. If 3/6 divided by 1/6, how many 1/6 are in 3/6 is 3. Then when I ask 3/6 divided by 2/6, how many something twice as big are in the same total? That would have to be half as many. 1.5.
Yeah. So I actually was just thinking while you were talking about how I thought about the first problem, like how many 2s are in 3. And so for this problem, you could think about how many 2/6 fit inside 3/6. So there's going to be 1 2/6 inside that 3/6, but I can only fit half of the 2/6 the second time. Like
in the leftover 1/6.
In the leftover.
So that's interesting. What I'm hearing you say is I've given you 3 problems. To do the third problem, first you thought about the second problem to help you.
Yeah.
But then you also said, but I could also think about the first problem to help me.
Yep.
So listeners, this might be, if you've never actually pulled out a pen and pencil while you're listening to the podcast, this one might be one that you want to. Yeah. So So if we can just focus on how you use the first problem, it's almost like I hear you saying the first problem you thought about 3 divided by 2. You thought about how many 2s are in 3. And the third problem, 3/6 divided by 2/6, you thought about how many 2/6 are in 3/6. It's almost like you were thinking about how many 2 somethings could fit into 3 somethings. And in the first problem, you were like 2 holes. How many 2 holes could fit into 3 holes? And in the third problem, you thought how many 2 1/6 could fit into 3 1/6. And both times the answer was 1.5. 1.5 of those 2 whatevers could fit into those 3 whatevers. Interesting. Okay. Next problem. 3/5 divided by 1/5.
3 1/5
fit into 3 1/5.
Fit into 3/5.
Okay, so 3/5 divided by 1.
Did I say that wrong?
No, you said it right. Okay. It's just depending on how you're. Okay, so 3/5 divided by 1/5 is 3. Yep. Cool. Next problem. 3/5 divided by 2/5.
So 2/5 can fit inside of 3/5 one time, and then half again. So it's going to be 1.5.
Again.
Oh, and that looks like the first problem, Pam.
Say more.
3. You said 3 of something divided by 2 of something. It has been 1.5. So 3 1/5 divided by 2 1/5 is still going to be 1.5.
Still 1.5. So yeah. I wonder, like, I'm adding a problem late in the game here. So if I said something like 3/7 divided by 2/7,
yeah, you
think it still might be
1.5?
1.5. What if it was? Yep. What if it was 3 29ths divided by 2 29ths?
Yep.
Still one and a
Still
half?
1.5. Yep.
Because I can, two whatevers can fit 1.5 times into 3 whatevers.
Yeah.
Whatever they are. Interesting.
Yep.
Interesting.
Yep.
All right. Next problem of the string. 10 divided by 9.
Well, you're asking me to think quotitively. So 9 can fit into 10 one time. And then
But there's some stuff left over.
there's some stuff left over. And 9 can fit into the stuff left over only 1/9. So 1 and 1/9.
10. You're saying 10 divided by 9 is 1 and 1/9?
Yeah.
Say that. Why again?
Because 9 can fit.
How many 9s are in 10? You're thinking about how many 9s are in 10. Sorry to interrupt.
Yep, that's okay. So 9 can fit into 10 one full time.
And then there's what left over?
There's a 10th left over.
I think there's 1 left over. Yeah.
Oh.
A tenth of 10 is 1.
Sorry. So it can fit into 10 one time, and then there's 1 left over, and then 9 can only fit into that 1 left over 1/9. 1/9. It can't fit the whole time. It's just 1/9.
You can only get 1/9. Yeah.
Yeah.
There's only, yeah. That's it. That's crazy kind of like reasoning, right? That's interesting.
Yeah.
So I have on my paper written 10 division sign 9 equals 1 and 1/9.
Yes.
I also want to remind us that sometimes we can write 10 divided by 9 as 10 fraction bar 9.
Yeah.
10 ninths.
Yep.
And is 10 ninths equivalent to 1 and 1/9, like you just reasoned quotatively?
Yes. It is.
Sure enough. So a couple different connections that we can make. Now, I kind of forced you to think quotatively. And you were like, all right, I can think about how many 9s fit into 10. And well done doing that. But we could also sort of, that connection between division and fractions, we can think about 10 divided by 9 as 10 ninths. Cool. Nice thinking. All right, ready? Next problem. 10 twelfths, so the fraction 10 twelfths, divided by 9 twelfths. 10 twelfths divided by 9 twelfths.
9 twelfths fits inside 10 twelfths one time.
With some stuff left over.
And there's a 12th left over. And 9 twelfths can fit into 1/12 and 9th.
Like it really doesn't fit, right? It's only
it doesn't fit. It can only fit into 1/9.
That 1/9 left
but
over.
you know what would have been like a little bit easier for me?
Okay. Go ahead.
If I had thought about the problem before. And what we kind of just talked about.
Yeah.
And 10 twelfths, the thing is the twelfths. So 10 something, 10 twelfths divided by 9 something, 9 twelfths is going to be the same. It's an equivalent answer to 10 divided by 9. So it's still 1 and 1/9.
So you're saying 10 twelfths divided by 9 twelfths is still is equivalent to 10 divided by 9. Because it's almost like 10 things divided by 9 things.
Yep.
Is 10 divided by 9, which is 1 and 1/9 or 10 ninths.
Yep.
Fascinating. Okay. So similar to what we were doing before, if we can kind of think about 10 ninths, 10 divided by 9, we can think about 10 anythings divided by 9 anythings is still going to be equivalent to 10 ninths.
Yep.
Cool. All right. Next problem. How about 5/6 divided by 3/4? Now, this isn't related to anything we've done, so just brand new problem. 5/6 divided by 3.
Well, I'm glad I've been writing the problems down because...
So, listeners, you might want to actually take the advice we had, which you're writing stuff down.
So, 5, I'm comparing the problem you just gave me and the problem prior to that. So, 5/6, holy cow, 5/6 is equivalent to 10 twelfths. From the previous problem. And 3/4 is equivalent to the 9 twelfths in the previous problem.
Okay.
So the answer is going to be the same, 1 and 1/9.
Or 10 ninths. So, Kim, what did you think, though? Like, when you saw 5/6 divided by 3/4, is there a first thought that you thought, okay, how many 3/4 are in? Or did you just go, it's a problem string, I'm going to see if they're equivalent?
I totally did. I'm not going to lie. I totally did. I was like, there's got to be something here because that problem is funky.
Well, so when you said that problem's funky, then I actually want to pause that brief second because I think you really quickly were like, that problem is funky. It's a problem string. I'm going to look for a pattern. I'm going to look for
Yep.
something.
Yep.
And I think we could potentially kind of skip over the fact that you actually considered 5/6 divided by 3/4 first. Like mathematicians consider that. You don't just look to see.
Oh, yeah. I looked
Yeah.
at it and I thought about it and I was like, ugh.
And then you said to yourself, what else do I know?
Yeah.
Oh, great mathematical
Yes.
thinking. And you're like,
Yes.
hey, sweet. It's equivalent to the
Yeah.
problem before. Bam. So the answer is going to be equivalent.
Yeah.
Let's maybe parse out a little bit. What 5/6 divided by 3/4,
Mm-hmm.
you like you could think about how many 3/4 are in 5/6. And then that's like, wow, like fourths and sixths, and those are not delightfully related
Right.
in like a super, like if I just cut them in half, I get the other one or whatever. So then you kind of said to yourself, since they're not, I wonder what else I know. And yeah, the problem before was just sitting there. But in a way, the problem before, when you said, what else do I know? You kind of found a problem that had the same sort of pieces.
Mm-hmm.
Like often when we add and subtract fractions, we say to ourselves, oh, I can't really add 6 and 4. So let me find equivalent fractions that have the same kind of pieces, maybe twelfths. And then, hey, I could add them together. It's almost like this time you said to yourself, I wonder if I could find the same number of pieces so that I could divide.
Mm.
I don't know that we typically have done that,
Yeah.
teachers. I wonder, like when you said 5/6 divided 3/4. Hey, but they both can turn into twelfths, and if I can turn them both into twelfths, then I could just think about the twelfths. And
Yeah.
then,
So I think there's two things that happen too that I'm aware of that I want for our students, like
yeah,
in this moment,
uh-huh.
is one, what I was going to say to you is I think this is the funkiest problem that we've done in the last couple of
Episodes,
episodes.
yeah,
And I want for kids to think about the fact that there are kind of different, I don't want to say levels of problems, but like some are a little funkier than others. And
mm,
so like I want them to be a little bit more discerning about, I have this variety of strategies and this problem is one that I might have to think about a little bit differently. But also, I know you just gave me the 10/12 divided by 9/12,
hmm
but I looked at it and was like, oh, those are equivalent. So I had to know that those were equivalent to be able
mm,
to make use of it.
absolutely. Hey, one other thing that we should probably mention is in this problem string, if I was doing it with students and not Kim, a thing that I guess I could have done it with you too, but I might have said, hey, let's actually talk about 5/6 and 3/4. How do they
Yeah.
relate? If I'm
Yep.
asking how many 3/4 fit into 5/6, am I going to have a lot of 3/4 in 5/6?
Yeah.
Am I going to have, is the answer a fraction? I mean, 3/4 doesn't fit. Is 3/4 less than 5/6? Like, how do those relate? And Kim, how would you answer that? How do those relate?
The first
Like
thing
just
I'm thinking about, go
relative
ahead.
size. I was just going to say just relative size, but go ahead. What was the first thing you were thinking of?
Well, so I know that I know a lot about 3/4. And so I was actually thinking about what's 3/4 of 6 to see if 5/6 is more than 3/4 or less than 3/4.
Okay. All right. Let's go there in a minute. Can we slow that down a little bit?
sorry,
I want to
sorry,
slow
sorry.
I want to slow you down just a handful. So if we were just to compare 5/6 and 3/4, which one's bigger?
5/6.
5/6.
But
And
but
go
but I
ahead.
had to know that because I had to think about what I know about 3/4.
Sure, sure. And in that way, we would want to do some work with students. 5/6 is just one unit fraction away from 6/6. It's just 1/6 away from 6/6. And 3/4 is just one unit fraction, 1/4 away
Yep.
from 4/4. And so I can think about what's bigger, 1/4 or 1/6. And that can help me think about what's closer to 1. Since
Mhm.
1/6 is smaller than 1/4, 5/6 is closer to 1 than 3/4. And so now I
Mhm.
have this comparison. 3/4 is smaller than 5/6. So when I ask how many 3/4 are in 5/6, I should get an answer of, well, at least one and some extra, right?
Mhm.
Did I say that right? Okay, cool.
Yeah.
Then I could go to what you were talking about, that
Well,
you
I
could
think I
think about
compared as well. I just compared in a different way than you did. I think it's the same, like
kind
we
of,
were both seeking to compare.
interesting. What is three
You were
fourths of six?
uh
I
so
think your way's more multiplicative. I'll just say that. Mine was less
oh,
multiplicative. Mine was
okay.
more based on the definition of fractions. And I think yours
Okay.
was a bit more multiplicative. So you said 3/4 of 6. Why would you ask 3/4 of 6?
Because I know I have 5/1/6,
Uh-huh.
and I want to know if that's more than 3/4 or less than 3/4. So
Mm-hmm.
I thought about what is 3/4 of 6, and I know that it's 4.5. So if 4.5/6 is 3/4, then 5/6 is going to be more than 3/4.
I love it. That's brilliant thinking. Well done. All right, cool.
Moving on.
So the upshot of this problem is we could
Shoot.
look at a cranky problem like 5/6
Yep.
divided by 3/4, and we could say
Yep.
to ourselves, I wonder if we could find the same kind of pieces and then deal with that problem. So you said,
Yeah.
yeah, I know
Yeah.
10/12 divided by 9/12. Bam, I can think about that like 10 divided by 9. Woo!
Yep.
Cool, last problem. Set.
Okay.
9 divided by 4. What's 9 divided by 4?
I just took a deep breath too. There's a lot of talking. Okay. So I
A lot of
know,
thinking.
yeah. So I'm going to say that is, I can fit 2 4s in 9. 2 4s in 9. So then I'm going to say 2 and a fourth.
2 and 1/4. Because
Yep.
2 fours is 8. So you've got 1 left over.
Yep.
And then you're thinking about how many 4s are in 1.
Yep.
And you're like, that's a fourth. 1/4.
Yep. Yep.
Okay, cool. So 9 divided by 4 is 2 1/4. Could I also remind you that we could think about that as 9/4?
Yep.
So
Yep.
9 divided by 4 is 9/4. 2 1/4. Those are all equivalent. We want all that going on.
Yep.
Cool. Next question. What's 9/12 divided by 4/12?
That's 9. It's similar to 9 divided by 4, so it's still going to be 2 1/4.
Because
Because I have 9 somethings divided by 4 somethings. So that's the same as 9 divided by 4. I could fit 4/12 into 9/12 twice and a fourth again.
another fourth left over. Cool.
Mm-hmm.
Cool. So similarly, if I know something about 9 divided by 4, then I can reason about 9 anythings divided by 4 anythings would
Yep.
also have that equivalent 9/4 solution. Nice. Last problem.
Yep.
3/4 divided by 1/3. How many 1/3 are in 3/4?
That's nice. It really is, because I'm thinking about how I can scale both those up, and I could use 12ths. I could use a couple of different things, but I'm going to go with 12ths. And
Mhm.
if I scale the 3/4, that would be equivalent to 9/12. And if I scale the 1/3 to 12ths, that would be 4/12. And then I land back in the same place where it's 9/12 divided by 4/12, or 9 divided by 4, which is 2 1/4.
So you're saying the answer to 3/4 divided by 1/3 is 2 1/4 because it's equivalent to the two problems that we did before.
Yeah.
Or 9/4, either one.
I'm going to go
All right.
looking for problems like these.
Nice. So y'all, fraction division is figure outable.
Wow.
And we want to spend time helping students reason about fractions, reason about partitive and quotative, and we've only been kind of focusing on quotative division. We will do more episodes later where we focus on partitive division for fractions, but I wanted to kind of think about this problem string that we did today, and I want to take a slightly different, what we just kind of ended with. If I have fractions that are kind of gnarly, like 5/6 divided by 3/4, we said to or 3/4 divided by 1/3, we said to ourselves, I wonder if I could find equivalent, if I could create an equivalent problem where I could think about the same denominator, same kind of pieces. Then I could kind of reason about it. Like that last one, 3/4 divided by 1/3. Bam, I can think about that as equivalent to 9/12 divided by 4/12. Oh, well, that's equivalent to 9 divided by 4. Anything. 9 anything's divided by 4 anythings. And so we sort of think about that. If I could just maybe leave you with what we just did was think about finding common denominators in order to divide. But what we didn't do was tell kids that, hey, when you divide, find common denominators. It's not a rule that we're telling kids. It's relationships we're developing as we actually reason through the math. And you might be like, Pam, why do we want to stress kids out? Can't we just tell them what to do and let them do it? It's so much easier. Well, what's your goal? If your goal is to get answers in the easiest way possible, why are you not just using ChatGPT or Google or a calculator? Or like, if your goal is to get the answers the easiest way possible, then go for it. But if your goal is to develop reasoners and mathematicians and help kids think more and more sophisticatedly, then division of fractions is figure-outable. Y'all, thanks for tuning in and teaching more and more real math. To find out more about the Math is Figure-Outable movement, visit mathisfigureoutable.com. Thanks for joining us, and let's keep spreading the word that math is figure-outable. Thank you for listening and making math more figure-outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure-outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.